Hello and good morning. This today's topic is second law of thermodynamics: Carnot cycle, heat pump, refrigeration cycle, reversible, irreversible cycle. Anyway, these are the recap of basic thermodynamics, which is required for this course. So I'll be going through the topics quickly, and the topics I have selected from PKNAG, Basic and Applied Thermodynamics, Tata McGraw-Hill book. So qualitative difference between heat and work. Certain first law says the certain energy balance will hold and the system when the system undergoes thermodynamic process. But it does not give indication of the change of state or process is feasible or not. Okay, so it says trans energy and work uh, can be convertible, but it does not say the feasible or not. Does not say does not say about feasibility. Okay, heat and energy are not completely interchangeable. Okay, heat or energy not completely interchangeable actually in first law, but heat and energy not interchangeable. Uh, not completely interchangeable. Okay, so when work is converted into heat, so work is converted into heat, W is work, Q is heat, then 100% conversion possible. When heat is converted into work in closed process, so 100% conversion not possible. So Q arrow shows direction. Okay, so this is work is converted 100%, but heat is not converted. Okay, so if you see one thing, like heat, all the final form, all the form of energy, whatever is there. So whenever you convert, you do anything, so final form will be heat actually. So whenever work is being converted into heat, so some work, there will be no loss actually. Finally, everything will be heat. But whenever heat is converted to work, so some heat you cannot use actually. Okay, that's why heat will be higher, work will be lower. But when work is going to heat, so everything is heat finally. Okay, so let's say one process 1 to 1. Okay, process 1 to 2, again going back to 1 and giving work 1 to 2, heat 2 to 1. So W1 2 to 2 equals Q2 to 1. Okay, but in other case, if you consider 1 to 1 same, Q1 to 2, W2 to 1, W2 to 1 cyclic process happening. So in that case, Q1 to 2 more than W2 to 1. Okay, so this figure says qualitative distinction between heat and work. Qualitative distinction between heat and work. Work is said to be high grade energy. Work, high grade energy. Okay. Q, low grade energy. Low grade. Okay. The complete conversion of low grade to high grade is impossible. Okay, so complete of low grade to high grade is impossible. Okay, now we'll go to cyclic heat engine. A heat engine cycle is a thermodynamic cycle in which there is a net heat transfer to the system and a net work transfer from the system. The system which executes a heat engine is called heat cycle. Heat engine cycle is called heat engine. Okay. A heat engine cycle is thermodynamic cycle in which there is net heat transfer. Okay. Now first to draw one figure. Q is coming and Q2 is going out system. Okay. Figure says like heat engine cycle. Heat engine cycle performed by a closed system undergoing from successive energy interaction with the surrounding. Interaction with the surroundings. Okay. So cycle heat engine, you draw one another figure. This is turbine. Turbine is there. So turbine will be giving work output. Turbine work WT, and this turbine is getting work from boiler. You have one boiler. Okay. From boiler you will get a turbine will get energy, and after turbine there will be one condenser. So condenser actually it will be releasing heat. Q, heat release. So turbine work output. Okay. And from condenser there will be one pump. From pump to again boiler. So certain steam you take, so steam will go to turbine. Turbine will be extracting certain power. So the turbine will get power. Then after that the steam will go to condenser. So when it is going to condenser, steam will get liquid water again. So that water will be pumped to boiler again. Boiler will be giving lots of heat. Okay. So boiler will get furnace heat, or I can say furnace here. Okay. So furnace means lots of heat will be generated, and that heat will go to boiler. So this whole cycle will continue your steam power plant or your steam engine, wherein steam engines are there. Later we'll discuss in details. So this whole cycle will be there: turbine, condenser, pump, boiler. Then water will be circulating continuously. Okay, so that water will not go outside of the whole cycle, but heat and energy will go in and out. Okay. So heat engine cycle performed by steady flow system interacting with surrounding. Okay. So this was cyclic heat exchanger. So the net heat transfer in cycle either of the heat engine Q net, Q1 minus Q2. So Q1 is here. Q1 it is you are giving Q1 minus Q2. So this is net heat input. So net work transfer. Net work transfer in a cycle. W net equals WT minus W pump. So pump will be requiring power. W pump. Okay. To run pump you need extra work input. Okay. Or I can write W net equals W E minus W C. Compression. You can say W E means expansion, W C means compression. Okay, that is also okay. So first loss is summation of Q equals summation of W cycle. Okay, so Q net equals W net. Net input, heat input equals net W work output. So Q1 minus Q2 equals W turbine minus W pump. Okay. Now, if I draw whole thing in one simple cycle, okay, like this, I have this system. So what is coming? H2O liquid coming, then Q1 H2O gas. Okay, turbine work going out, H2O coming in, uh, then pump work going in, uh, okay, turbine are going out, and Q2 is going out, Q1 is going in, Q2 going out. So Q1 minus Q2 equals WT minus WP, turbine power minus pump power. So now cyclic heat engine with energy interaction represents in a block diagram. So if efficiency of a heat engine eta equals net work output of the cycle divided by total heat input to the cycle equals W net divided by Q1. So eta equals W net by Q1 equals Wt minus Wp divided by Q1 equals Q2 minus Q1 minus Q2 divided by Q1. So eta equals 1 minus Q2 divided by Q1. So this is also known as thermal efficiency of a heat engine. So this is also known as thermal efficiency of a heat engine. Energy reservoir. A thermal energy reservoir, TER, thermal energy reservoir hot, from which heat Q is transferred to the system operating in a heat engine cycle called source. Okay, so reservoir is called source. So I'll have one TERH or source. Okay, it is coming to one system. So system will have like turbine output, pump input, pump work input, turbine work output, and one reservoir, the source, sink. Okay, TER, this is low temperature L, this is high temperature H. Okay, and this is Q1 coming and Q2 coming here. Okay, now TERL or Q rejected to sink. Okay,